Hi, guys. Before we get into our investigation about mountains and plate motion, we need to understand what mountains are. So, a mountain is a large natural elevation of Earth's surface. And so, basically, a large natural rise in Earth's surface. And over here, I took a look at Googled a picture of the Himalayan mountains, which are the most famous mountain ranges that people are able to see from a satellite above. They're the highest mountains in the world. So after watching me do the simulation in Amplify, you should be able to answer this question. Do convergent or divergent plate motions cause mountains to form? We are going to do the Amplify simulation to gather evidence for whether claim 1 or claim 2 is true. So claim 1, mountains are formed when plates move apart at divergent boundaries, or claim 2, mountains are formed when plates move towards each other at convergent boundaries. So let's move on to our simulation. And what we are going to do is we are going to investigate basically two plates that are on land. So I am making one big large continent with a green boundary line to represent our plate boundary. And we are going to set the boundary as divergent, which is our first possible claim. And when I click on run, you need to mainly focus your observations on this cross-section view below, okay? And make sure you are understanding this is a divergent boundary. We're gonna click on run, and I'm gonna click active volcanoes and earthquakes very soon. And you can see the time is ticking, 78 million years, 90 something million years. And we're going to go all the way to the very end. Remember, earthquakes are represented by dots. Volcanoes are by triangles. And 200 million years have passed. Let's take a look at this cross-section view. Ask yourself, do you see a rise in the Earth's surface? Now, let's go back to build. And let's clear the boundary. And let's reset the boundary as convergent, which is our claim 2. Remember, when I click run, focus your eyes, your observations should be about this cross-section view. And we're looking for a rise in Earth's surface. So let's click run. And take a look at this cross-section view. 90 something million years, 100 something million years have passed. Remember, the orange is the mantle, the brown are the plates, basically our crust, and 200 million years. And this is the cross-section view that's happening. Okay, so there you have it. You have gathered enough observations to be able to decide on whether claim 1 or claim 2 is true. See you guys later in the next video.